Okay, for today's presentation, we're going to go through something a little bit different. We're going to talk about auditing the calibration process. The reason we're going to go through this is I've gotten some feedback on methods people are using to try and claim credit for auditing calibration, including just checking stickers or just checking gauge IDs, if you want to say it that way. And that is really not a process audit for this requirement of the standard. So we're going to review what's required to audit calibration. As always, we want to relate it to the DQS quality policy. We want to do process-oriented audits and walk you through some question sequence on that. We're going to confirm the effectiveness of the management system that includes the calibration process. And we want to make sure we're doing a thorough audit so that our certificates are internationally respected. Okay, let's just jump right into it. First of all, do all gauges need to be calibrated? This is always a question when we talk about this requirement of the standard, because you'll walk through a factory and you'll walk up to a control panel and there'll be hundreds of gauges on it. And the question is always, does this need to be calibrated? Or you'll see somebody using a tape measure to make an inspection. There's always a discussion about whether tape measures need to be calibrated. And here are your rules for determining whether something needs to be calibrated or not according to the standard. Are they being used to make a decision about product conformance? So either at receiving process or final inspection. So if it's a defined inspection as part of the quality system and they're doing it with a gauge, that gauge needs to be calibrated. If they're doing a first article or a PPAP, those gauges need to be calibrated. If the gauge is being used to control a process parameter for a special process, and we're going to walk through an example on the next page, that gauge needs to be calibrated. And then gauges used as part of product verification and validation need to be calibrated. So it doesn't matter what the gauge is, it really matters where and how it's being used in the quality management system. Okay, so here's our example. So you're auditing a plating process. There are 12 different baths, and you walk up and you're in front of this big panel with all these temperature gauges here. Here's your 12 temperature gauges. The drawing requires a thickness of 0.2 mil, no other requirements. The client's process control identifies baths 4 and 5 as requiring temperature control. What needs to be calibrated? So this is the toughest scenario for us to deal with. And really, it's down to how the customer, what is required of that process, and how the customer is defining process control. So in this case, it's only a thickness. I didn't say anything about adhesion or any of the other properties that might be considered in a plating process. And the customer has identified that they do want baths 4 and 5, which probably have to do with concentrations, to be temperature controlled. So in that case, all these gauges that you see on here don't necessarily need to be calibrated. Only a couple of them, the ones controlling baths 4 and 5, would need to be calibrated. So those of you that are plating experts probably like Dave, are saying, Dave, that was a really simple example and you really kind of downplayed that. But I don't want to go overly complex here. I want to illustrate the point that when you walk up to one of these machines, don't automatically default and say, oh, all these are gauges, so they have to be calibrated. It really matters as to how the process control is being defined. In a case like this, it could have none of them being calibrated if they say, we test every batch for thickness, and they could show you evidence of that sort of control. Okay, examples where a gauge would not need to be calibrated. So a lot of times if you're observing a setup, you'll see them using gauges to measure certain things. They're doing that to make sure the setup is correct, so it cuts down on their time. But the real control of that process may be done through something like a first piece inspection. So therefore, those gauges used in the setup would not need to be controlled. Gauges used for preventive maintenance might not need to be controlled. Machine gauges where parameters, we just talked about this, the special processes. I gave you an example. And gauges used by engineering as part of early design concepts like the building of breadboards, where they're not selling the product, they're just using it for demonstration concept. Those might not need to be calibrated. Is it a good idea to calibrate these gauges? Sure. I mean, Would you want to go through a whole setup thinking you got the whole thing done and then find out when you run the first piece that it was off because the gauge you used to measure some parameter of it was incorrect? That would be inefficient, but it would not result in the shipping of non-conforming product, and it's up to them to define what they want to do in terms of how their process is controlled and works. Okay, the assessment of calibration, now that we've determined what gauges are in and what gauges are out, happens two different places. It happens when you're out on the floor. There's a couple things you're going to look at. You're going to look at it that it's suitable for the use. You're going to look that the gauges are maintained, that they're identified to determine their status, and that they're safeguarded from adjustment, damage, or deterioration. And then there's a bunch of stuff you're going to do when you audit the actual process of gauge calibration, how they know gauges are calibrated and everything is done on its required frequency, which is another requirement of the cost. So the first thing you're going to see out on the floor is whether the gauge is capable. Some programs might have requirements for accuracy, like the MSA manual spells out some accuracy type requirements. Most programs do not. As a rule of thumb, you'd want to see 4 times to 10 times more accuracy in a transfer standard from what's being measured. So we'll talk about that with this example over here. You want to have the operator show you how they inspect the part. That's another way of knowing whether the gauge is capable or not. So let's just look over here at our example. We got this nice little part here, and we're measuring this the inside side of the caliper. We're measuring this dimension here. So the part is being measured at 5 millimeters plus or minus 0.001. Being using a caliper. Is the gauge capable? Well, hopefully most of you said immediately, no, Dave, because look at the reading right there on the gauge. It doesn't go that far out. We can't determine if we're plus or minus 0.001. So what would you want to use for this? Well, you need something that's more accurate than a caliper, and that would be a micrometer. But you have to be careful, because if you consider most micrometers, they tend to have this side of the gauge. And what you don't want to see is somebody taking a mic and trying to eyeball this dimension here, kind of put it up against it and see if it's about right. Because look, you're trying to hold this 0.001 tolerance. You're not going to be able to eyeball that. What is the finding? Finding is the gauge is not capable. Is it a major? Probably not. There's some things you could do to make sure they're not shipping non-conforming product, but this is probably not going to be a major. Is the gauge identified? So this is where you're looking for your stickers, color-coded bands. So that's maybe they put a yellow mark on this, and that means it has to be calibrated every January. Etched gauges where the operator can relate the gauge to a calibration status. So in a very oily environment, the stickers don't stay on or they get damaged. So they'll etch a gauge number in, and then they'll have a list of gauges and when they're supposed to be calibrated. Safeguarding from adjustment, damage, deterioration. Might ask the operator, where do they keep their gauges when they're not in use? Look around. Do you see them being damaged? Do they look like they're bent? Those are things that you observe when you're out on the floor. And while you're out there, you get your gauge numbers and location, and that's going to be your samples for assessing the calibration process from the office side. Okay, here is a sequence of questioning for getting through the calibration process. I highly recommend you use this sequence. It's time-tested and true. Can you show me the system that you use? Know when a gauge is due for calibration. They may show you a spreadsheet. They may show you a gauge track. They got to show you something, some sort of monitoring system that enables them to know when something is due. When they show you that, do you have any gauges that are past due for calibration? So if they have 100 gauges and they show you the system and 50 of them are past due, how do we feel about the effectiveness of the system? Not good. Could be a major nonconformance. That is why you're asking that question. Is this tracking system working? How often is a gauge XYZ calibrated? They're supposed to be done at specified intervals. They need to define those intervals. Is there a method defined for calibrating the gauge? You want to check that gauges are calibrated across the range of views. So a lot of times they'll say, oh, I take my caliper and I put it on the 1-inch block. Well, if I'm using that caliper to measure things that are a half inch, 1 inch, 10 inches, depending on the size of the caliper, maybe just a single point check is not going to be sufficient to know that it is calibrated across its full range. You also want to see defined acceptance criteria for the calibration. So when they take that caliper and put it on a gauge block, how do they know it's passing? How do they know it's failing? They have to define that acceptance criteria. When you see them do this, you want to know that the standard they're using to calibrate something is traceable to NIST. I'm using shorthand here. Traceable to international or national measurement standards is what the ISO standard says. So if you're looking at that caliper and they show you how they do it with a gauge block, your next question should be, oh, since you're using gauge blocks, can you show me that those are calibrated? Generally, your transfer standards are going to have external calibration, so they send them out of house to be calibrated. You will want to take a look at the certificate. When you get that certificate, you need to make sure that you check it and see that it has traceability to NIST. I'm just going to shorthand it again. You need to read the record and make sure that that external record that you're looking at doesn't have things that are outside spec. So don't just get a look at it. It should have actual as found results. That's what you're looking at to make sure that they were good as found. There wasn't an out of tolerance condition. You also want to make sure your standard is accurate enough to achieve the required calibration accuracy. So this happens a lot of times when the transfer standard is not a gauge box. So let's say I have go, no-go pins. And they'll say, well, we calibrate these pins, which are usually good to 3 decimal places, with a caliper, which is usually accurate to 2 or 3 decimal places. Really, to get that 4 times to 10 times accuracy, they should do it with a micrometer. Can you show me the records? So you want to look at the results. You want to see if the results are recorded and whether there are any acceptance criteria and whether things were within the acceptance criteria. Whether in your sample you find anything out of tolerance or not, you need to ask what the process is when a gauge is to be found out of calibration. I've been surprised at how few of the systems I've audited in the last year have actually had this requirement being met. And I've been surprised because this has been a requirement in the ISO standard 1987 version of the standard. Even if you do not see a sample where a gauge was found out of tolerance, you need to still test that system. You need to see that it's documented. You need to ask them what they would do. You can ask them if they've had any that have been out of tolerance. But you need to make sure they have that process. You need to make sure what that process includes going back as far as the last known good calibration. So if they calibrate gauges annually, and upon calibration, the as found condition is out of calibration, well, they're going to have to go back a ways to make sure that those test results for the gauge they were using, just yesterday to measure product as conforming are still good test results. Okay, so what do your notes look like? I, again, highly recommend the table. Now, this is from my notes, so you can see it's really messy because I'm not a good writer, and you can see, like, I said type here, but I actually put the gauge number, and I put the gauge type here. But what you really should be looking at is, what was I looking at? Here I got micrometer, I got calipers, I got a spark tester, I have a tape measure. I have a cross-section of the gauges. This particular company, that's basically the gauges they had. They didn't have much more than that. I have the location I found them. I had whether acceptance criteria was there. They had procedures for calibration. The frequency was defined. It was traceable in this. And the gauges were identified. There you go. And then when something was off, I have a little AR. That's how I mark my ARs. I have a little statement here about out of tolerance conditions, and I had something on document control that I was looking at. That's it. You don't need extensive notes. This is roughly 2 hours of auditing a calibration process. And you can see it was done on about a half a page of notes. What does your section 3 look like? Okay, so the important part of all this, and this is section 3 from a different, not related to the notes, it's from a different report. The important part of all this is the sample. This is what you want to have noted here. How many did you sample? And you can make some statements if you want about, it could be traced, whether it could be traced in this. Here was a 1 gauge, it could not be traced in this, so there was an AR associated with this. Some that were missing acceptance criteria, so minor nonconformance was noted. Okay, so it's pretty straightforward how to document calibration. And again, the important thing is the sample size. And with that, calibration is a lot more than just looking at the stickers. If that's what you're doing, you're not doing a process audit, you're on the floor, your checking gauges are capable, identified, safeguarded, and protected, you're collecting your sample. The office, what you're really trying to do is make sure things are being calibrated per their schedule, and then it's all traceable back to a nationally or internationally recognized standard, and make sure your sample is cross-sectional, and make sure you get a healthy sample of gauges. And that's it. Thank you for your attention.